Hello, this is Jason Clement, Technical Sales Manager at Isonis, and welcome to the Certification Training Module. This module is Access Control, the basics. Our course objectives are to understand how card readers operate and the common technology used, understand what peripheral devices operate alongside a card reader, understand how access control integrates to fire alarm and life safety systems, and understand how legacy access control panels operate. So how do proximity readers work? The proximity card has a coil of wire inside and other circuitry that store the credential number. The reader generates a radio frequency in tune with the card, typically either 125 kilohertz or 13.56 megahertz. When the card is presented close to the reader, it absorbs that energy. That energy is then used to send the credential information back to the reader in the form of binary ones and zeros. Cards that operate this way are called passive cards. Now, some cards have a small battery that increase the range in which it can be read. These are called active cards. There's also a lot of technology for vehicle gates and parking garages and things like that, where you can have passive cards and you can have very long read ranges. However, those readers typically take a lot of power. We can interface to them through the IP bridge, which we'll talk about in later modules. So the reader and the card technology, we talked about 125 kilohertz. That's been the standard for decades. Probably 80 to 90% of the cards out there are 125 kilohertz cards. The new technology is 13.56 megahertz, or what we typically call smart cards, iClass, MyFair, PIV, etc. These have better security. 125 kilohertz, when I present my card, there's no encryption there. It's just the binary is going right into the reader. With the smart cards, there's actually encryption between the card and the reader. There's also memory on the card that can be used for banking, other application data, storing fingerprint biometrics. There's all kinds of things you can do with these. They're very popular over in Europe, and they're gaining popularity here as well. Some readers also have keypads embedded. So these can be used to do various things. We can do a PIN unlock in case somebody forgets their card. They can enter in their 4-digit PIN and still get in the building. We can also do dual authentication, so kind of the opposite. If they lose their card and somebody else picks it up that's not supposed to be allowed access into the building and they read it, they can't get in because they have to have the card swipe and a 4-digit PIN to be able to get in, so it's an additional layer of security. Isonis also has a unique feature we'll talk about in future modules where we can actually control up to 4 different doors through a single card reader. The weakened interface is used by the reader to communicate to legacy panels. So we talked about the card sends this binary information to the reader. The reader then translates that and sends it through this weakened interface to the control panel, which then will take that information and determine the card number and other things from that data. OSDP, or Open Supervised Device Protocol, is a new interface for readers to communicate to the panel. Basically gives two-way communication between the reader and the panel, similar to RS-485, but it's already an outdated technology. We all know that IP is going to win, just like in the case of the IP cameras and the VMSs. So what type of different electric locks are out there? There's two primary types. Fail-safe locks become unlocked when power is removed, so in order to stay locked, they have to have power applied to them. And the opposite are fail-secure locks, so these become locked when power is removed, and when you need to unlock the door, you apply power to it. The picture on the left is a magnetic lock. It's always fail-safe. These are very popular, especially on glass front doors where you don't have a lot of real estate or you don't have room to put an electric strike in there. So these generate a magnetic field, and then you have a piece of metal on the actual door itself, and when it gets close, the magnetic field pulls it close and keeps the door locked. Again, that is a fail-safe lock, so power is applied to keep the door locked. And then you have your typical electric strikes. These can be fail-safe or fail-secure, depending on the needs. So then we have electric mortise locks and electric cylindrical locks. These are the same things as an electric strike, except typically the locking mechanism is built into the door. So you'll have a power transfer hinge where your wire will come through, and then the door will come pre-equipped with the wiring through the door and around into the lock for you. So all you have to do is tie your wires on. Electrified exit hardware is usually the big crash bars or locking pins that go up into the top of the door. These sometimes have a dedicated power supply as they require high current. So we're just going to trigger an input on that power supply to unlock those doors when needed. These are typically always fail secure locks. So what type of peripheral devices? If we think of an access control system, really it's just inputs and outputs. Even the reader is an input. The reader is sending data to the system, and then we're using that data to determine where they have access. And then a lock is an output. We're routing power and we're unlocking that door. But there's so much more that we can do with the system. So typically you'll have a door sensor monitor, or a door contact on the door, and a request to exit motion, or a button. The door contact tells us when the door is open, and the motion tells us when there's somebody that's actually exiting out the non-secure side, so it doesn't trigger a false alarm. We can also add sounders or strobes. So if we have that pesky door on the back of the warehouse that people keep leaving open and propped open all the time, after 2 minutes, if we have a piezo or a light on there, we can trigger that to notify somebody that, hey, this door is propped open, so they can close it and fix any security loopholes. And then we also have entry or lockdown buttons, very popular in schools. So once something happens, they hit that button, it locks down all the doors, and it can also disallow people access, and it can only allow a certain special group of people access into the building. There's a lot you can do with those entry and lockdown buttons. So really, we can take any input that can be monitor any device that has an open-close alarm state. So we take a look at motion detectors and glass breaks. Typically, these are wired to an intrusion panel, but we can wire these into the access control system and create alerts through there as well. Low temp or high temp or water sensors, we can tie those in and have those trigger alerts to us. And also machines. If we have a lot of machines in a facility, we want to know if something's overheating or something may be damaged. It could send out an alarm to the access control system and alert somebody that way as well. And likewise, there's a lot of different things that we can control through the outputs. Data center racks. A lot of data centers now are controlling access to every single rack in there, so they know who's been in what rack. In case something comes up disturbed or some data comes up missing or damaged, they can go back and see who read in to get into that rack to access the physical equipment. And also in medical facilities, the PCs that are locked up in the room, we want to know who's got in there, if there's any medication or anything in there. We have an electronic audit trail now instead of the typical old somebody signed in 6 months ago when we looked at the actual paper log itself. We can control machines. So if we only have certain people that are certified to use those machines, we can put a reader on there and control the access to that machine. So if Bob says to Jim, hey, go run this machine, and Jim's not certified, he's not going to be able to do that unless he has a card that gives him access to there. So once he completes his training, then he can be added to the access group that controls that, and he's good. One other thing is forklifts, the same thing. Only the people who are safely trained to be able to operate those forklifts should be able to use those. So we can, again, create an audit trail to see who's been on that forklift and when they've been on it. The other thing, one of the major things is fire alarm and life safety, and this gets overlooked sometimes with access control. And really, when we have to interface to this becomes our issue as well as the fire alarm contractors. So a fail-secure lock can be as simple as a reader and a lock, and typically these are very easy. I can turn the handle, I can exit out. It's a fail-secure door, so I can typically always get out there. Now when I have a fail-safe door, I have power applied to there all the time. So if there's an emergency, I need to be able to get out that door without any hassle. So at the minimum, on the door you'll need 2 exit devices. One typically being a request to exit motion above the door, and the second being an exit button near the door or some type of crash bar to be able to get out. This is for if one device fails, you can always fall back to the second device to be able to exit out that door. Now, if you have a fire alarm system, fail-safe doors must unlock and stay unlocked until the alarm has been cleared. And we can't do this via software input. Most people think, well, okay, I just take one output from the fire alarm, I tie it into my access control system, and then I create a trigger that just unlocks everything. What happens if that server goes down and it's not able to unlock everything? We have to have basically a manual unlocking device from the fire alarm contractor to be able to trigger, to trip power to those locks so that people can get out safely. And this can be done in a variety of methods, which we'll talk about in later modules. Note that local AHJs have the final say and may require additional functionality for safety purposes. On the same side, the AHJs may allow for lower functionality, but really in the end, you are the integrator and you could be held accountable if somebody is injured during a fire alarm. So it's best to just meet the code as much as possible, even if the AHJ lets certain things slide. So here's what a typical door with an electric strike looks like. On the secure side, we have a card reader, and you can usually see the electric strike from that side. You can actually get face plates that cover it up so nobody can get in there with a screwdriver or anything to be able to tamper with the lock. And then on the non-secure side, we have a request to exit motion or a door sensor. We don't need these, but it's nice to know when the door is open and who's been through it. So how does it work? When we're entering from the secure side, we present an authorized credential that unlocks the door and bypasses the door contact for entry. When we go to exit, the request to exit motion senses the person close to the door and bypasses the door sensor, allowing the person to exit without causing an alarm. Now, a typical door with a magnetic lock on the secure side, typically all we'll see is the card reader. On the non-secure side, like we discussed, we'll have a request to exit motion. We'll have our mag lock and door contact. A lot of mag locks have door contacts built in, makes it a lot easier now. And we'll have our exit button as our secondary form of egress. So again, when we enter, an authorized credential will unlock the door and bypass the door contact for entry. On exiting, the request to exit sensor will sense the person exiting. It unlocks the door and bypasses the door sensor for the person to exit. Now, if the request to exit motion fails or it doesn't trigger, they can hit the exit button and that will unlock the door for a specified amount of time. Typically, it's 30 seconds because if it's a couple feet from the door, I can't hold the exit button and then try to turn the door. We want it to trigger for an actual set amount of time. And if we need fire alarm unlocking, then we'll tie that into the fire alarm panel. So how do legacy panel-based systems work? So the proximity readers communicate to an access control panel via its Wiegand or OSDP on proprietary wiring. All the other peripheral devices wire back to that control panel as well. That central panel is typically plugged into the network and communicates back to a host running on a server. So the host manages all the panel connections, stores all the configuration and history data in the database. So course review, we talked about how card readers operate and the common technology used, the 125 kilohertz and 13.56 megahertz on the smart card side. Understand what peripheral devices operate alongside a card reader. Typically, you'll have an electric lock, a door contact, and request to exit devices, but we can really do so much more than that. Basically, anything that we can input into the system and anything we can control with an output. We talked about how access control integrates to fire alarm and life safety systems and how critical that is. And we took a look at how basic legacy access control panels operate so that we can see how ISONAS really operates much better at a lower price point than the other legacy applications out there now. Thank you for attending this module, and we look forward to seeing you in the next modules. Have a great day.